In this section, we'll work on the player's health bar and shooting bullets in enemies. We'll also learn how to respawn the player at a specific position after they're destroyed, with a delay of a few seconds. Next, we will implement the radar system for the players. Go to the prefabs folder and add the tanks bullet from cartoon tank free to the scene. Then, in the prefabs folder, add the turret bullet from Mathematic Free Machine to the scene as well. Assign appropriate titles to each of these bullets and replace their names accordingly. Select the enemy turret projectile object and press F to focus on it. Disable these 3 bullets that belong to the players and do the same for enemy turret projectile. Select the enemy missile yellow object and attach a box collider component to it. Do the same for the other tank bullets as well. Select the cube from enemy turret projectile, copy the box collider component attached to it, and then paste it into enemy turret projectile. Select these 3 objects and enable them again. Do the same for this one as well. Select all of these bullets, right-click and choose Unpack completely from prefabs to remove them from their prefab state. In this section, we will work on the enemy bullets, so we don't need these bullets for now. Temporarily disable them as well as this one. Select all of these objects again, and this time add a rigid body component to them. Next, select enemy missile yellow and create a new script called bullet. attach it to the object. Select the tool handle rotation and change it from global to local. Then, open the bullet script in Visual Studio. Here, we define some fields that will be used for the bullet, including the RB variable, which we will use to move the bullet. Add the OH method and use getComponent to assign the RB reference. In the start method, we call the addForce method on RB to apply force along the forward direction to the bullet. This force is applied in impulse mode to ensure it is applied instantly. Next, we call the destroy method so that after the specified destroy time has passed, the bullet object is destroyed. We don't need this method, so we'll delete these lines and replace them with the onCollisionInter method. Here we use the try_getComponent method to get a reference to a damageable from the object we have collided with in the if statement. If successful, we return this reference using the damage variable, so we can use it later. Thing to note is that we haven't created the iDamageable script yet, so without wasting any time, let's return to Unity and create this script, which will be an interface. So by selecting Assets and right-clicking, we create a script called iDamageable. Then we open it in Visual Studio. Since this script is going to be an interface, we don't need monoBehavior and replace class with the interface keyword. We also don't need the existing code, so we'll delete all these lines. In this interface, we declare the takeDamage method, which takes damage and hit point as input parameters. Next, we go back to the bullet script and in onCollisionInter call the takeDamage method on the damageable variable. Finally, we call destroy to remove the game object. Save the script and implement the iDamageable interface for both the enemies and the players. Then return to Unity. Select the enemy missile yellow object and enter player in the for which tag field. Then go to the sample scene, click play and run the game. If you noticed, the enemy missile yellow moves forward and it destroyed after 5 seconds, showing that the bullet script is working correctly. Stop the game and return to scene 1. Select the enemy missile yellow object, copy the bullet component and paste it onto enemy turret projectile. Add the bullet script to the players as well and set the for which tag field to enemy. To make all these bullets able to spawn over the network, we need to add another component in addition to the existing ones. So add the Photon View component to all the bullets. To synchronize the movement of all these bullets in the game, and since we're using rigid body to move them this time, we also need to add the Photon Rigidbody View component to all the bullets. Return to Unity, add this component and check the necessary options. Note that for the player bullets, we set enemy in the for which tag field, while for the enemy bullets, we set player. Select all of these objects, enable them, and place them in the resources folder so they can be turned into prefabs. We no longer need any of these objects in the scene, so delete them all. Next, select enemy turret and open it in Visual Studio. In the script that opens, we define the fire method. This method will make the enemy turret shoot bullets at specified time intervals. So here, we define a few fields related to this functionality. We use these three fields to create a timer for shooting bullets. In this field, we will have the bullet that is going to be spawned. And this field will be used for the bullet's spawn point. Now returning to the fire method. We first check whether the firing flag is false. If this condition is met, we use the instantiate method to spawn the bullet at the spawn point. Set is firing to true and set fire rate timer equal to fire rate. In the else block, we implement the timer, and once the time passes and its firing becomes false, this process repeats. Now, we call the fire rate method in update whenever the player is within range. Save the script. So here, as explained, we call the fire method and instantiate the bullet prefab using this line of code. We've also added these new variables to the script. Now, return to Unity and assign the required field for the enemy turret. For the fire point field, we need to add the fire point object to the enemy turret and then assign it. Fortunately, a fire point object has already been created and correctly oriented, so we can use it. Select the enemy turret and assign this object to the corresponding field. Now save scene 1 return to sample scene and run the game once. Here we encounter a null reference exception error. This happens because when the bullet is fired, it collides with an object that doesn't have the iDamageable component, so it cannot call the take damage method. Press F to focus on it. As you can see, there are a few issues here that need to be fixed. The first problem is that the attached box collider is too large and need to be smaller. The second issue, which we mentioned earlier, could be because iDamageable is not attached to the train, so it doesn't have the take damage method. However, in reality, try-get component shouldn't cause this problem. Stop the game and fix these two issues together. So double-click on any meteorite projectile to open it in the prefab editor. Click the Edit Collider button and adjust the size of the box collider. And check the box collider for the other bullets as well. It seems the colliders are fine now. To address the second issue, go to the bullet script. Here, we want to make sure that if the bullet collides with the ground, which is assigned to the ground layer, it will be ignored. So in the existing condition, we compare the game objects layer with the ground layer using the nameToLayer method. If they match, we ignore it. So we use the not equal operator in the if statement. Let's check what name has been assigned to the train layer. Go to Scene 1 and select the train. It seems the name ground is being used. So we use this name in nameToLayer and then return to sample scene and the bullet script. Save the script and return to Unity. Then run the game once more. If you notice, there are no more issues, but the bullet that hits the tank has large mass and causing too much recoil. This recoil happens because the force applied to the bullet's rigid body is of type impulse. So stop the game, go back to the scene, and reduce the mass attribute in the rigid body for all bullets. Run the game once more. Here the previous issue no longer occurs. Next, we want to work on the radar system as well as the rotation of the player's name and health bar. So stop the game and open Player Blue in the prefab editor. If you remember, we previously added the UI Manager script to local canvas. Double-click this script and open it in Visual Studio. Hold the Ctrl key and press R twice to rename this script to Player Local UI Manager. Here we define the health bar field and the change health bar method, which reduces the fill amount of the health bar according to the value received in the amount parameter. Save the script and then copy the same code and paste it into the Player World UI Manager script. Next, define the player nickname text field and rename the health bar field to Player Health Bar Image. Repeat the same changes in Player Local UI Manager as well. Return to Player World UI Manager and define the Photon View variable set nickname method. In this method, set player nickname text equal to nickname. Return to Unity. Next, we want the player's name and health bar to be synchronized over the network. To do this, we need to use RPC calls. So go back to the PlayerUIManager script. Copy and paste these two methods here and add the RPC prefix so they have different names. Then to make sure they are recognized as RPC methods, also add the PanRPC attribute. To call these methods, we use Photon View and the RPC method, just like before, as you can see here. Save the script and return to Unity. Select the world canvas object and add the Photon View component to it. Then assign the fields defined in the script. Do the same for local canvas as well. Next, open the Player Observer script in Visual Studio and write where the player spawns call the setNickName method from the PlayerUIManager component and passing the nickname property of the local player from the Photon Network class as the input parameter. So in this line, we are actually calling the setNickName method. After calling the setNickName method, in this line we call the RPC method. Next, go to the player controller script and work on the take damage method and defining a few new fields. In here we have the health and RB variables. And then we define the player local UI manager and player world UI manager variables. In the start method, we assign the rigid body reference to RB and then proceed to define the take damage method. Here, we check if health has dropped below 0. If the condition is met, we set the rigid body's kinematic property to true. Disable the player locking system component and disable the box collider attached to the player. Finally, we call the destroy and respawn method in player observer and passing the player's position as a parameter. And then return to prevent the following lines from executing. If health is still above 0, it gradually decreases by the amount of damage the player receives. And the change health bar methods in Player Local UI Manager and Player World UI Manager update the health bars accordingly. Next, press Alt and Enter to create the Destroy and Respawn Player method in Player Observer. Then press F12 to navigate to this method. In this method, we call the Destroy and Respawn Player coroutine. In this coroutine, the player object is destroyed after 3 seconds and then seven seconds after being destroyed, it is respawned at the same position. These lines are executed in this method and these lines are executed in this method. Save the script and return to Unity. Now assign these fields in Player Controller. Assign the Player Local UI Manager object for the local UI and the Player World UI Manager object for the World UI. Next, select Player Namespace and set the Y-axis value to 0. Return to the scene and run the game once more. If you notice, even though there is no apparent issue and the turret bullet is being destroyed, the player's health doesn't decrease, and the health bars in local canvas and world canvas aren't updating. It seems the take damage method isn't being called at all. So stop the game and go to the bullet script. In the if statement, we mistakenly placed a not operator at the beginning of the first part of the condition. This caused the problem. Even though the bullet hits the tank and the iDamageable interface exists in player controller, the condition never passes, so the take damage method isn't called. We need to remove this not operator from the first part of the condition. The second part of the condition is fine and works correctly. Save the script, return to Unity, and run the game once more. It seems everything is working correctly now and there are no issues. And after the player is destroyed, it respawns at the same position after 10 seconds. Next, we want to work on the radar system and we'll have the map visible in here, and the indicator layer will no longer be rendered by the gameplay camera. So stop the game and continue working, and open Player Blue in the prefab editor. First, make sure that the world indicator is assigned to the indicator layer, and do the same for the indicator object. Next, select the main camera and in the cooling mask uncheck the indicator layer so that this layer is no longer rendered by the main camera. Right-click on the Assets folder, go to Create, Rendering, and select Render Texture. Rename it to Minimap Render Texture. For the size, set both X and Y values to 512. Right-click on Player Blue and add a camera to this object. Rename it to Minimap Camera Renderer and position it appropriately here. Assign the Minimap Render Texture object to the camera's output texture field. Now, in the cooling mask, uncheck all layers except indicator and ground, since we want this camera to render only these two layers. In the environment component, set background type to solid color and in projection, choose orthographic instead of perspective. The size value will be adjusted during gameplay. Next, we select the camera renderer object and then we assign it to the texture field of the Minimap renderer texture object. Now it renders the ground and indicator layers for the Minimap camera renderer object. Now we go back to the scene, we run the game, and then we set the rest of the settings. First, in the new camera we added, we need to remove the audio listener component. Second, we rotate this camera 90 degrees around the x-axis, and for the height from the ground, we set Y to 12. Third, the size in the projection for now, we set it to 20. We will adjust these values later. I think 20 might be better for the height. We stop the game and go back to the scene. Then we open Player Blue one more time. Now we select Minimap camera renderer. We set Y to 20. We also set size to 20. Then we remove the audio listener components. For rotation around the x-axis, we set it to 90. Run the game one more time. Apparently, the radar system is working correctly. We just need to make the turret indicator a bit bigger. The size should be good. We wait a bit for the tank to appear. The two enemy indicators are almost the same size. That's exactly what we wanted. We stop the game and go back to scene 1. And then we set both the width and height to 100. We go to sample scene and then we run the game one more time. For size in Minimap camera renderer, 23 works better. So we stop the game, we select player blue and set size to 23. We select the player controller script and open it in Visual Studio. To make this part of the code work over the network, we add this if statement at the start of the take damage method. In start after line 52, we also add this code. The object we reference is the one the camera is attached to, which is the radar system camera. These three objects are the ones we need to remove for non-local players. So we save the script and go back to Unity. We go back to the scene. This time, let's test in mobile mode. So we go to Player Blue and we check there is mobile box in the input controller. Then we run the game. If you noticed, the radar ratio compared to the controllers isn't correct and it's a bit too small. So we select radar mask and set appropriate values for width and height. I think 280 would be better. We stop the game and go back to the scene. We select Player Blue and set radar mask to 270. And we also adjust the object's position a bit. There are no more issues, and we go back to the scene. We go to scene 1. And now we add all the players to the scene. Next, we want to add everything that was added to player blue, to player red, and player green as well. So first, we select this object and copy it. Then we paste it into player green and place it in this section. We set the position in X and Z to 0. The next is the player local UI manager script, which it was already added to the local canvas object. And we just need to assign the player health bar image field. And the next one is world canvas, which should be selected in player green and have the player world UI manager script attached to it. Just like player blue, we assign all the fields of this script. First, for the photon view field, we need to add the photon view component. And for the next two fields, we assign their corresponding objects. We also change this to 0. At the follow, we select main camera and uncheck the indicator in the cooling mask. And for Minimap camera renderer, we check both indicator and ground layers. Since this object was copied from the player blue, all the settings are already applied. Select the player green object and assign these two fields as well. We select the radar mask object for player blue. We copy the rect transform component and paste it into the rect transform component of the radar mask in player green. Next, we open radar mask and select camera renderer. And we assign the Minimap renderer texture object to the texture field. Now we need to do the same for player red. So just follow the same steps without any extra explanations. Now it's time to override all the prefabs so that all the changes are applied to them. We no longer need this in scene 1, so we delete them all. Now we go to sample scene and run the game one more time. Apparently, everything is working fine and there are no issues. We stop the game and go back to scene 1. Now we want enemy tank to shoot bullets at the player just like enemy turrets. So first we need to open the enemy unit tank script in Visual Studio. We open the enemy unit turret script and we copy the methods and fields needed for shooting bullets and use them in enemy unit tank. So we copy this method from here and paste it at this line in enemy unit tank. And we also define the fire method. For the variables used in this function, we go to enemy unit turret and add all the necessary ones to this script. So we copy all these lines and paste them into this script. We save the script and go back to Unity. We create the necessary objects and assign them to their corresponding fields. We assign this object to the bullet prefab field, and for the fire point field, we right-click on this object and create an empty object. We rename it to fire point and place it here. Next, we select enemy tank and assign the fire point object to the corresponding field. Next, we open PlayerUIManager in the prefab editor. We uncheck the Is Mobile box in the input controller field, and then we go back to scene 1. Here we select one of the bullet prefabs. If you noticed, we haven't used the field name for which tag in the bullet script, so we can remove this field from the script. Here we are using the destroy method to remove the bullets. But keep it in mind, this doesn't actually destroy the object across the whole network. At the follow, we want to use the RPC method to destroy this object. It makes sure that the destroy happens across the entire network. So we define the RPC destroy bullet method and add the pawn RPC attribute above of this method. And we place this line of code here. As you know, calling RPC methods requires a photon view. So here we define this variable. And in the awake method, we set the reference for this variable. We no longer need this line, and we replace it with a call to RPC destroy bullet method. Instead of this version of the destroy method, we use a coroutine. We call and define destroy bullet coroutine so that the bullet destroys itself automatically after destroy time. Next, we copy this line and paste it in this section. So we can delete these items as well. and we save the script and go back to Unity. Then we go to sample scene and run the game once more time.